Hey, what's up, everyone? Alissa Knight here. I am so grateful to be this year's keynote speaker at BugCrowd's LevelUp conference. I want to thank BugCrowd for allowing me to speak on my recent research, Scorched Earth, how I hacked 55 banks and cryptocurrency exchanges through their APIs. So without further ado, let's get started. I like to start my presentations out with this quote. If I were to advise a hostile nation state on how to take down the US financial system, I would tell them to start with the APIs first. Our financial services infrastructure is a carefully woven fabric of APIs that are allowing financial services and fintech companies all to talk to each other. APIs are ubiquitous across every industry, not just financial services, but also healthcare and even passenger transport vehicles. Yeah, pretty much every car made after 2001 communicates with an API. So if you think you're not impervious to being hacked because you're not driving around in a Tesla, think again. Anyway, so this quote really just underscores the threat that we are all facing today, no matter what the sector is. We've moved away from this world of monolithic applications to APIs, where applications are talking to applications and devices to applications, all being powered and plumbed through APIs. APIs have pretty much become the plumbing for our entire world. I'm always telling people cyberspace is the ultimate equalizer. I don't have the resources, the money, or the military superiority of the United States, for example, yet just being able to target and breach APIs, I have the ability to take down major critical infrastructure simply because these APIs are unprotected. And this research that I'm going to be presenting to you today underscores how serious of a problem it can be when things like our financial system is not properly hardened with API security solutions. So for those of you who don't know who I am, and if this is our first time being introduced, it's nice to meet you. I'm Alissa Knight. I'm going to talk a little bit about who I am and my background, what the heck APIs are. I'm going to talk a little bit more about this research, the summary of findings, so screenshots and evidence in case you're thinking, you know what, Alissa, this sounds too crazy. There's no way you did this. I'll be presenting evidence today. And what I learned from robbing these banks from the comfort of my own home. And then I'm going to close this presentation with an Ask Me Anything, an opportunity for you to pretty much ask me any question you want. All right, so who am I? I was arrested for hacking a government network when I was 17. I like to say that I'm a recovering hacker. When the charges were subsequently dropped, I began working for the US intelligence community in cyber warfare. I'm a recovering hacker, recovering entrepreneur, recovering perfectionist, if you will, and an adversarial content creator. Now you're probably wondering, okay, Alyssa, what the heck is adversarial content? So I coined this term back in 2019 when I started creating white papers that demonstrated the efficacy of cybersecurity products by hacking something. I believe that CISOs, and we just in general, security engineers, are sick and tired of the typical marketing fodder of cybersecurity vendors, of their features and their capabilities and their machine learning. And I wanted to create a different kind of content. So I started a company called Night Inc. that basically disrupted cybersecurity marketing in general by creating these new form of white papers that tells the story through the lens of the adversary. So what I do is I hack a network and then show how the company's product would have prevented it, and if it didn't prevent it. So this is a concept I coined as adversarial content. I am a published author. I published the first book on hacking connected cars in 2019 under Wiley. Now I'm working on a new book on hacking APIs, and that will be coming out sometime this year under our own publishing company, Knight Publishing. Okay, so my experience in hacking APIs goes back quite a bit. I first started out hacking 30 financial services mobile apps and fintech mobile apps back in 2019. And then I hacked 30 mHealth apps. Don't ask me what's with the 30 app thing. I don't know. I ended up just starting out with 30 and it just kind of became a theme. So sticking to that thematic expression, I stayed with 30. So then I went on to hacking 30 mHealth apps and APIs, giving me access to millions of patient records, showing how vulnerable this mHealth API infrastructure is in this pandemic that we're living in now. In 2021, I also published research on hacking law enforcement vehicles remotely through APIs, actually demonstrating how I could lock and unlock the doors and start and stop the engine. Of course, with the law enforcement vehicle, that is incredibly dangerous. And then shortly later, began hacking fire APIs in the healthcare sector, fast healthcare interoperability and resources. This came out of 21st Century Cures Act as a mandate by Capitol Hill lawmakers to make healthcare payers and healthcare providers provide our patient data through FHIR APIs. And that report was called Playing with FHIR. You can download that report as well. And I'm also a cybersecurity filmmaker. And you're probably thinking, Alissa, oh my God, you're doing all these things. What the heck? What's with this filmmaker thing? So, building on the success of our adversarial content in written form, in written experience, we wanted to create visual experience. So my wife and I, Mel, formed Knight Studios, and now we are creating cinematic films for cybersecurity vendors, demonstrating the efficacy of their product in a story arc. So we are now filming in Hollywood and in Las Vegas, cinematic short films, basically bringing industrial light and magic to cybersecurity. And our new film is going to be premiering at AMC movie theaters at RSA in June. So we're super excited about that. All right, so let's move on. What exactly is an API? Right? You're probably thinking, okay, Alyssa, I don't understand. What is API? Well, when I walked into this, I really actually couldn't spell API. I had to learn along the way, like my other vulnerability research. But basically, the best way to describe APIs is it basically is glue that allows applications to talk to one another. Um, let's say, for example, in the analogy of a restaurant, we're all going to have something to eat. We look at the menus, we decide what we're going to order, we place that order with the waiter, and the waiter brings that order to the back end kitchen where the chef is going to cook it and then hopefully deliver back our food where we can eat it. This is a great analogy of an API consumer talking to an API, and that API requests the data from the backend servers and delivers it back to us as the API consumer. This could be a mobile app, it could be a car, it could be anything. So that's an API. So about the research, this I deviated from the 30 app history I had, but this was 55 apps made up of banks, neobanks, cryptocurrency exchanges. I wanted to go after all financial services and fintech. No victim was spared. Many of the APIs were deployed behind web application firewalls. Shame on you. Stop doing that. I get that APIs speak the HTTP protocol, but don't secure them like you would a web server. You need an API threat management solution, and this research is proving why you do and why WAFs fail. A majority of the APIs that I was able to breach in working with financial services companies were actually protected behind WAFs. And why do WAFs suck for securing APIs? Because of the fact that they don't understand business logic. They don't understand if I'm logged in as Alissa Knight, why am I requesting the data of Carl Mattson? That is an authorization vulnerability. I'm authenticated, but I'm not authorized to request a wire transfer from Carl's account or any of his financial information. None of the APIs I tested had undergone pen testing. I don't know what the deal is here. I think in my conversations with organizations, basically it came down to we were doing our required annual pen testing. We didn't have any APIs in development, and we didn't want them going after production APIs. They are talking to Venmo or these other P2P payment services or this fintech or this finserv, and they didn't want to risk it going down. So the APIs were left out of scope. Every organization, of course, is different in their reasoning, but whatever the reason is, it's not a good reason. Okay, so maybe you're thinking, oh, Alyssa, these were community banks. These were small banks that didn't have a cybersecurity budget. Of course, you were able to hack all these things. No. I wanted to provide some demographic information to all of you on my targets here in the sampling. The headquarters for the banks and credit unions were 19 in the United States. 4 of them had over 100,000 employees, 5 of them had over 50,000 employees. Assets under management, 11 had over 100 billion in assets, 4 of them had over 1 trillion in assets. And account holders, you're talking about 3 of the targets having over 11 million account holders. 2 of them had over 50 million account holders. So the demographics for the targets were all over the board. It wasn't a small company problem versus a big company problem. It's an all of us problem. The neobanks, those of you who don't know what a neobank is, it's basically digital bank. It's got no brick and mortar branches. It's the branchless bank. Headquarters 17, 3 were in the UK, 1 was in Canada. Number of employees, these were all over the board. Some of them had over 100 to 500 employees. Assets under management, some had over 5 billion to 10 billion in assets. I mean, these were not small companies. These were medium to large size organizations. Some had over 1 million to 10 million account holders. The cryptocurrency exchanges, 5 were in the US, 1 in the UK, 3 in Asia. Crypto under management between 1 and 1 billion. Account holders between 1.1 billion and 10 billion and held by customers. Assets under management over 10 billion. These are large organizations, right? Okay, so you're probably thinking, Alissa, this all sounds amazing. Get to the meat of the sandwich. All right, here it is. Are you sitting down? Are you ready for this? Okay. I was able to actually move money in and out of accounts using these vulnerabilities. A majority of the vulnerabilities were what are called broken object level authorization, or BOLA, and we will talk about that shortly. But I just want you to know that as long as I knew the account number, and we all know this isn't top secret, right? It's printed at the bottom of checks. Goodness, if you walk into a branch and open an account, you get an account number, then you can cycle through all of the other numbers because now that you've got the syntax. All right, able to change Visa debit PIN codes of any bank customer. If I knew the debit card number of any customer, and of course I could cycle through them as long as I had one, I could change the PIN code of any of the customer's debit cards. 2 most common vulnerabilities were API 1 2019, like I said, BOLA, and API 2 2019, or broken authentication. Coincidentally, OWASP API security top 10, number 1 and number 2. 54 of the 55 mobile apps that I reverse engineered contain hard-coded keys and tokens, as well as usernames and passwords. Shame, shame. Stop doing that. It is very easy to extract an Android app off of an Android device, throw it into something like Mobile Security Framework, and search for hard-coded keys and tokens and other API secrets. Stop doing it. I get that you have to do it, but at least make it hard for me by obfuscating the code. All of the apps, all of them were vulnerable to women in the middle text, or what I like to call WITM, or as many of you previously referred to it as man in the middle text. But basically, I was sitting in the communication session between the API client, like the mobile app or the web app, and then the backend APIs, sent SSL TLS certificates in both directions, and they thought they were communicating with the other end. It was really me, and I was able to decrypt the traffic and learn how the API worked. All right, the actual architecture of the attack. Again, this was me sitting in the middle. Postman, if you're in the audience, I love your tool. Call me. I would love to create content for you. But basically, ran the financial services mobile app on my mobile phone that communicated with my laptop, which was running either Burp Suite. These days, I'm using more Burp Suite. Previously, I would use Minim Proxy and Postman, and then I would copy and paste the captured packet in its header fields into Postman, send it to the API, and I'd be on my way off to the races. But I'm more lazy these days, so what I love about Burp Suite is I can stay within the tool and I can just use whatever module in it, whether it's proxy or replay, whatever. And also Mob SF, like I mentioned before, for static and dynamic code analysis. It's a great tool. Download it from GitHub. It's free. It's very powerful. All right, so you're probably thinking, okay, Alissa, Ebola, Ebola. No, not the disease that will kill you. BOLA. BOLA stands for Broken Object Level Authorization. I came up with this analogy. It made sense in my head. Maybe it doesn't make sense in yours, but this is how I like to explain it. Let's say Carl drives up in a Lamborghini. to a valet. And I'm like, I want that Lamborghini. I want to steal it. So I drive up behind Carl in my Daewoo or my Hyundai. Not that there's anything wrong with Hyundai, but I drive up in my Hyundai and I see that Carl gets the number 18 from the valet. I drive up behind him, and then the valet gives me number 17. I walk off, and then I use a Sharpie to change the 7 to an 8, and then I come back, valet, a different valet. I hopefully wait some time. Come back to valet with the ticket, and then drive off with Carl's Lamborghini because he didn't actually authorize me to drive away with his Lamborghini. It's the difference between authentication and authorization. That's the best analogy I can come up with. Basically, you're authenticated, you're allowed to pick up a car because you have the valet ticket, but you're not authorized to drive away with someone else's car. Same thing with an API. I'm authenticated, I'm allowed to talk to the API, but I'm not authorized to be able to wire money out of an account that doesn't belong to me or request information on the account holder from the APIs when it's not my account. Okay, that's BOLA. All right, so you're probably thinking, Alissa, I don't believe you. There's no way this was possible. Well, here's screenshots. So these are screenshots of the API keys and tokens that I found hard-coded in the apps. You guys and girls will notice Firebase. But there's some lovely, juicy Firebase stuff in there, as well as some other keys and tokens, and believe it or not, usernames and passwords, as well as credentials for AWS. These are some other screenshots. I was trying to figure out how to copy thousands of keys into a PowerPoint. I thought the best way was just take screenshots of my spreadsheets. You get the picture. All right. This is a screen capture of Minim Proxy, the way I used to do things. But here you can see the decrypted actual body of the API request where I've got the card number, the card type, the unique identifier, the name on the card. So this is basically the PIN information for the card and as well as the member account number. And then me just recreating it in Postman. Again, I love you, Postman. Thank you for your product. And then all of the data and information that I could send the backend APIs here, allowing me to then just change the PIN code to something else. And you can see a success here where I was able to specify a completely different card number, account number, change PIN codes, and of course, move money in and out of accounts. So in this one, I know it makes absolutely no sense because it's not blurred. No, this is not your monitor. It is not your eyes. It's me. This is real customer data. I didn't want to potentially compromise that. So I blurred all of it. But as you can see here, this is clear. This is not an error message. It's clear that this is actually the API sending data back to me. This was full account details on the account holder. Everything that the bank had on the account holder, I was able to pull out. All right, so what did I learn from robbing 55 banks from the comfort of my living room? Despite it being 2021, developers are still not authorizing authenticated API requests. You need to authenticate and authorize. And again, this was systemic. It's pretty much found in every API I've ever tested. Organizations are also not maintaining asset catalogs. A lot of the banks didn't know that those specific APIs I was hitting were still out there. You cannot protect what you don't know you have. All right. That's very important to know. Find an API security solution that will let you catalog your existing APIs and will notify you of new APIs coming online. As a CISO myself for a bank, I can tell you that one of the biggest complaints and issues that I had were the developers just throwing new APIs up into AWS or Azure and me not knowing about it. Shadow API problem, right? So context and security was another issue. Again, organizations are using WAFs. WAFs are looking for things like SQL injection, things you can build rules around, whereas API security solutions will be able to detect logic attacks like the ones I discussed, like BOLA. Many companies are actually transferring their risk. Okay, hopefully you're all still sitting down. This is the part where you're going to be able to hear a pin drop. Yes, one of the banks that I had actually hacked outsourced the development of their APIs in their mobile app to a third party. And that third party rinsed and reused that vulnerable code, and it affected 300 other banks. Oh yeah, that happened. I was on very long phone calls with the CEOs of the companies. it was a mess. If you're going to outsource, do not just ask for a copy of their SOC 2 Type 2 report and call it a day and say they're secure. Stop asking for just their ISO 27001 certification. When you're talking about APIs and how the criticality of what they're creating for you, you need to demand that pen testing be done. You need to trust but verify. You just don't want to transfer that kind of risk. If your APIs are breached, whose logo is going to be in the news? It's not going to be the company you outsource the development to. It's going to be yours, right? No pen testing. Guys and girls, you got to do pen testing. I don't know why APIs are not being deployed into development environments before they go into production. I don't understand how it's 2022 and we're still deploying straight into production. If you need to, have a mirror setup of your production environment for pen testers to hack. It's plain and simple. And that's it. You survived this keynote. So I hope all of you have an amazing conference. Have a great time. And this is your opportunity to ask me anything. And one of the last things I'll leave you with is if you're trying to figure out, gosh, I really like that Alissa Knight. How do I support her? Subscribe to my YouTube channel. Watch my videos. As cybersecurity influencers, which by the way did not exist 22 years ago, the best way you can support us is to watch and read our content and reshare it. Subscribe to our channels. Follow us on Twitter and LinkedIn, and talk to me. Reach out and talk to me. Say hi, and happy to answer any questions that you have. But thank you very much for your time, and I want to thank BugCrowd for inviting me to be the keynote speaker for this conference. And I appreciate all of you. And I've got some fans in the audience. I love you. I love all of you. Take care of yourselves and each other.